And I'm going to be talking about that today in this paper. So this paper was about the treatments that were very far from the WUI. But the first thing we wanted to ask is, I just went through those fire regimes with you, right? We wanted to know what percentage of the West is in these different kinds of fire regimes, and then we couched them in terms of need, right? Restoration need. So I'm saying it two ways. One is out of whack fire regime equal restoration need. Does that make sense? Is everybody with me? Hopefully. Okay, so here's the map. Here's what we found. And it's a little low for folks to see at the bottom of the screen, but this color here is fire regime group 1, and that is what we classified as maybe those are the places we should be looking for restoration. They're predicted to be in high restoration need. And I'm kind of saying those words slowly because it's not that every single stand would have high restoration need, but that they're in the type that could have high restoration need. It ends up it's about 25% of the West. If you look up here where we are, there's not a lot of that fire regime, right? It's not a lot of Montana, and I'll actually show you the number later. Okay, that brings me to, okay, so I've answered this. To what extent are fire adapted forests across the West in need of restoration? We found it was about 25%. So now, to what extent are the treatments located in the types of forests that need restoration? So that was the next thing we studied. And how you read this is the gray bar is the percentage of vegetation across the West. And the black and the hash bars are percentage of all the area treated in these 44,000 restoration treatments across 10 million hectares of land done by 5 federal agencies over a 5-year period. Okay, so we'll start with high restoration need, meaning high degree of fire regime alteration. It's on the bottom axis, and this is the area of all of those 44,000 treatments. And so I've already said 25%, so here you go. 25% of the West, 11 Western states, is in this category. And then in the low restoration need category, a little more than that, like 30. And look at this. Most of our forest in Montana, but elsewhere, about 45%, we kind of really don't need where they are. We really don't know where they are in terms of restoration need. Okay, so here we go. We had 46% of the area treated was in our potentially high restoration need category. Now, some of you might think, well, 45, it's higher than 25, so it means it was prioritized. So maybe that's good. Maybe the agency, maybe like gold star, right? However, if you look at it this way, we said we were doing restoration in 100 minus 46 is 64, right? Is that right? 54, thank you. You can tell I've been hiking a lot. I'm very relaxed, but my bucket is very, very full from all the hiking. But anyway, so over half of our restoration treatments are in forests that do not have their fire regimes degraded. No degradation of fire regimes.
Can I ask a clarifying question?
Yes.
My understanding was that the mixed is something we don't know enough to decide whether it's degraded or not.
That's true.
Is that correct?
No, that is correct. Okay. So we don't know.
Like shooting in the dark. Like,
yeah, we don't know. That's good. That's fair. But and then we've got this was, I don't know, 16% is in those, high severity, long frequency where we clearly shouldn't be doing them. Yeah. So anyway, I'm just showing you the pattern, and I think some folks might say, well, look, it's being prioritized, we're doing okay. Others might think, well, this is really a bad situation because we're putting treatments in where we don't know that there's need. Okay, so here's what it looks like for the different states, and the size of the circle is related to the proportional area treated across these states. So like, there was a lot more in Oregon. So here's Montana, little Montana. We didn't have so many treatments. The gray color again is that uncertain, and then you can see the small wedge that is this, what we're calling high restoration need category. Okay. So summary, only a quarter of forest area in the West is in the highly departed class. Federal managers, they did prioritize that class, right? It was more than expected, but less than half of all area treated was clearly in high restoration need. Given the extent of treated area and mixed severity types, we really need to get more information. I think this is really truly a priority need, is to understand what's going on in what is the majority of the types of forests that we have here in Montana, but also across the West. And then my big point is, it would be helpful if we were really clear about management objectives. So if we're installing treatments and trying to reduce fire hazard in forest types where we have fire regimes that are high severity fire, we should be calling them fire mitigation. And per the pictures that I started with, fire mitigation is an absolutely appropriate goal, an essential goal that we need to be working towards. But that's fire mitigation and is clearly not restoration. Okay. So now I want to talk about the biophysical considerations when we are working on fire mitigation. And then I have an example. So what do we worry about when we're trying to predict fire behavior? And conversely, when we're organizing treatments to reduce fire hazard, we worry about the amount of surface fuels, right? Because that's gonna predict your flame length. We worry about, going to the bottom here. Oh, shoot, okay, there we go. Going to the bottom here, we worry about the height to live crown, because that's gonna determine whether you're gonna get torching. So a flame length of a given height is going to have a different effect if height to live crown is higher or lower. Okay, that's the torching part. Then we worry about here crown bulk density, because once you get torching, if it's going to fire spread, you need to have crown packing, right? So you can manipulate all of these, but I saved for last over here surface fuel moisture, because the activities you do alter the moisture of your fuels. And we were just talking about this when we had dinner. Our wood in our forests has the capacity to gain and lose moisture with relative humidity in the atmosphere. And small fuels in particular will do that very quickly. Like, I don't know if anyone here has done any sampling for fuels, but the smallest fuel category is called a 1 hour fuel. And it goes in 1 hour, 63% of the way to equilibrium with moisture in there in 1 hour. Whereas the really big fuels can take 10,000 hours. So that's important, and I have an example to show you why. Okay. So, and this example is all about that treatments must be designed in the context of local conditions. And this is a nice paper that goes through that. So this is a simulation paper. It's kind of old, but I think it makes a really nice point. It's from Van Wagdentalk, and it's from the Sierra Nevada Ecosystem Management Project. And they did a simulation, 3,000 meters by 6,000 meter area, had a 20% slope, right? And then this is where they ignited the fire. And so there were a total of 8 treatments, okay? First was a control. Second was a prescribed fire. Third was a pile and burn, where they basically increased the height to live crown by pruning. And then they burned the piles. And then the cut and scatter was the exact same, except they scattered the material that they had pruned off the trees. Okay, then they did those exact same 4 with a thinning to make the full 8 treatments. So they for this one, it was a thinning, here's a thinning and a burning, and then the same two, piling and cutting. And what I want to go through is the size, the fire size, which is this oval, and the flame lengths that they found. So, oh, whoops, what am I doing? Sorry, I got ahead of myself. Okay, so here we go. So here's their control in their model, and the fire size is here. So it's a little over 400 hectares, and the flame length was about 1.3. Here's the prescribed burn they did. It reduced the area of the fire. It reduced the flame length. And these data from the simulation are for immediately after. So with the prescribed fire, you would expect over time that you would get more surface fuels. So it's a little more complicated than what I'm talking about here. But why this is working is because you've increased your height to live crown, and they accomplished a 50% reduction in fuels. Okay. Here's the cut and scatter. Here the area has increased. The flame length also is higher in their simulation. And then let's go down here to the biomass and cut and scatter. So this is, they did a thinning. They scattered the material. So this decreased the height to crown, but the fuels were adversely affected because of more moisture. So they got torching only, but the fire area, intensity, and severity increased. So what's important is not what happened in the simulation, but to say that it matters what you do in your treatment to be able to accomplish fire mitigation and reduce fire hazard. And it depends on the local context. So in my view, how we talk about doing fire mitigation treatments, it's often very generic, like it's so important, we have to get out, we don't have time to think, we want to make sure we are getting these treatments in. But actually, if we want to make sure we have a good treatment that is going to reduce fire hazard, we have to think about all four of those factors, including the fuel moisture. Okay, so this is my last slide. I have it as a topic, my fifth topic, but just because I feel so strongly about it. So I've put here this big, coarse, woody debris. When we're talking about restoration, we need to think holistically about each of these key ecosystem attributes rather than a narrow objective. So in the case of fire mitigation, we're talking about one process, really. We're really focused on that. We're not thinking about if a fire doesn't come through, if we do fire mitigation treatments or restoration treatments, depending where you are on the landscape. If we are thinking about the benefits of these treatments in terms of if a wildfire were to occur on that stand, in that stand only, then we may be doing treatments that we wish we hadn't done later. And so what I'm thinking about here in particular is coarse woody debris. We call it fuels when in the context of fire. It's also future soil wood, right? It's the sponge that protects mycorrhizae through the season. I mentioned the fact that large pieces of wood take longer to dry out, and they're like keystone players in our soils, disproportionately important. And so when we're doing restoration, in the context of restoration, you would want to think about species composition, structural diversity, ecosystem functions overall, external exchanges, all of these built into your restoration project. And specifically were projects where we're manipulating, forest structure in order to reduce fire hazard, right? If at the end of the treatment, most of them will not experience a fire. We don't have time to really talk about that, but I think we need to think about this as though there won't be a fire. Will this activity be good for this particular forest stand or ecosystem in the absence of fire, a wildfire coming through? And if the answer is no, because you're going to have compaction, invasives, other kinds of things, it would probably give me pause to continue to do that treatment in the context of restoration. In the context of fire mitigation, if we're calling it fire mitigation, absolutely, right? Back to those first pictures that I showed. We have to worry about people, lives, property, smoke, all of that. So with that, I'll stop. I put my contact information here. It's really lovely to be here tonight. I'm thrilled that instead of being outside enjoying the beautiful evening, you've shared your time with me here tonight. So thank you.